Hello and welcome to this video for Electropages. I'm your host, Robin Mitchell. Today we're here at PCIM in Nuremberg for 2025 and it's been a fantastic event and we've seen so many interesting power-related electronics coming into the market. Now today we're at the Cissoid stand and I'm joined by my very good friend Mike, which we saw last year at PCIM 2024.
Hi Robin.
Fantastic. So just before we dive into all the products that you're going to show us today, just tell the audience who you are, what you do and what you like to do in your free time.
All right, I'm Mike Sandyck. I'm marketing director with Cissoid. Free time is mostly reading, music, doing yoga, of all things. But yeah, that's myself.
Fantastic. So just tell us what exactly is going on here today at this show and what you are offering to customers.
So what's new this year is that we've started a cooperation with a German company called EDA Group, and they've taken our reference design and made it thermally and mechanically really optimized. So they've gone down in weight and up in thermal performance really significantly by taking our existing reference design.
So could you just go through some of the changes they've made and how they've managed to make it smaller?
So what's new about this inverter is that it's been optimized thermally and mechanically. So they've taken the volume down by 26% and the weight by 44%.
God, that's massive.
Yes.
Sorry, 44% weight reduction.
Yes. So because ours is a milled aluminum piece, and this is really optimized in weight.
And these are designed to be on vehicles. So as over there, we're going to see in a minute, we've got a racing vehicle which is all electric. And so like you're saying, using these modern silicon carbide devices, you not only can you improve the efficiency, but you're also getting the weight down as well.
Well, yeah, it's mainly in the housing construction. So we are helping customers to get that next step into industrialization. So our reference designs are made to make a proof of concept or a prototype, but then you need the next steps as well. So to take those next steps, you need something that's really manufacturable, and that's where we then partner up with companies who are really experts in that. Also, what they've done is they've improved the thermal performance, and that means we now go up to about 93 kilowatts per liter in power density. So that's really massive. And it's still not, we're not scraping the bottom of the barrel yet.
So you can go further?
Yes, we can.
How far do you think you can take it?
Well, theoretically, we should be able to take it up to 600, 650 kilowatts.
650 kilowatts is a theoretical maximum?
That's the peak performance, and we define a peak as 60 seconds, so it's not a 1 second peak, but a sustained 60-second performance peak.
But just out of curiosity though, so these types of electric racing vehicles, what kind of acceleration are we talking about from like 0 to 60?
Ooh, at that kind of weight, it should be in the 4 or 5 seconds.
And if you're then getting towards the 600 kilowatts, you think that'd be a lot quicker?
Well, the thing is, with this race car, because it's Formula 4, it's limited in horsepower that it can put out. So they don't pull out the maximum performance because it's meant to be training. I see. It becomes really dangerous.
See, I must apologize at this point. I have absolutely no clue about how Formula 1 works or how these different sort of like classes work. So I'm completely ignorant in this area of engineering. So I have a question about that actually, which is that in the sort of the racing environment, why is it going electric?
Well, the reason the Electric Racing Academy, as they're called, are doing it is, they have a lot less issues with the neighbors around the racing track when these guys are running. And it's a whole new way of racing as well, because you get the possibility to recuperate energy by braking on the motor. But that's really something that needs a lot of training.
And also, I'm guessing when you want to take energy back, this is where bidirectional systems come in.
Yes.
That's why things like silicon carbide and all these new technologies that you're developing are so critical for this type of racing sport.
Yes.
Yeah. So can you just sort of go through what's going on here in terms of electronics? Because this looks very fascinating.
So what we have here, these are our basic products. So we have them with a flat base plate heat sink, yes, or a pin fin one.
Right. So, whoa! What's that?
So that's yes. So the cooling fluid is pushed through either from left to right or the other way around. Doesn't really matter. It's omnidirectional.
I've never seen a heatsink like that in my life.
You'll find several around here. but it's really the most optimal way to evacuate a lot of heat.
I can imagine.
Yeah, because you need to get a few kilowatt of heat out of this.
And that's when this is when you're working at like hundreds of kilowatts as well. So
Yes.
so even though you say, oh, we've got to get kilowatts of energy out, it sounds wasted, but it's not, because the amount of power this thing is dealing with is so massive. Even a tiny percentage off on the efficiency results in a huge amount of power.
Exactly. So if, for example, you're running at 100 kilowatts and you have an IGBT inverter, the old style, you lose 4 or 5% of efficiency.
4 or 5 kilowatts.
Exactly. And if you bring that down to 1 or 2%, that's only 1 or 2 kilowatts of heat that you need to get out.
Huge amount of power to get rid of. So
yes.
So that's why these, even though it looks like it looks like a lot of power, it's actually not by comparison to what it's actually sort of driving through the system.
Exactly.
Fantastic. So what your business is providing to customers is these types of modules and these reference designs, but what you had here was something that you sort of put together yourself to show how it could be used in an end application.
Exactly. So the latest on our inverter control modules, which are unique in the market, by the way, is that they're ASIL-ready certified. So we've taken them further because our customers are starting to go into production. They need a qualification, so we're going through the automotive qualifications with the modules on their own as well.
I've never heard of ASIL before. What exactly is that?
So it's safety integrated level. I forgot what the A stands for, but it's a safety level that your module can guarantee.
Right.
So especially for autonomous vehicles, it needs to be as safe as it can be.
So how does it compare to something like AC 100 qualified for a component?
Well, that's one thing is the quality of the module.
Right.
So for a module, it's AQG 324, which is the automotive qualification.
Yeah.
The comparable standard to AEC-Q 100 or 200 for components. So that's the module level.
Oh, I see. So it's kind of similar in what it is, except that one's module, one's component. So that's why. And then I guess if you go even bigger, there will be another standard around that as well.
Yes.
That actually does make sense. And one thing I actually wanted to ask as well is in terms of like the reference designs. I'm guessing that this is something that allows your customers to take better advantage of your products, which is why you produce the reference designs in the first place.
Yes, exactly.
Yeah.
So what's unique in our offering is that from the power modules, so from the switching themselves, we can take you up to the hardware and the software and offer the complete solution. The unique thing about it is it's completely open. So up to which level a customer wants to use it, they can do so.
It's open source, as in like they can use it.
Well, it's not open source, but you can buy the licenses to change the software.
And then you can change, but you've got the ability to make the modifications you need.
Exactly. So we've got a proven design. You can bolt it onto a vehicle, start running within days actually. Get your proof of concept done, and then you can start customizing it.
Days?
Yes.
So that sounds quite unique. Would you say that not many businesses can match that to what you're doing?
Exactly. Yeah. So and you can get an inverter off the shelf, of course.
Yeah.
There are companies selling those, but then try to modify it and get the support to do that.
That's going to be hard. That's not going to happen
unless you're the major tier ones of this world. You struggle to do that. So that's really the unique offering that we have. We can give you the bits and pieces to build it yourself, but then you need the man years to develop it. Or you can take the proven design and then start to modify it.
And then what that allows engineers to do as well is not only decrease the time for prototyping and research and development, but also the time to market is decreased as well. So you can effectively get ahead of the competition before even anyone else has had a chance to start.
Yes, that's the whole goal. And that's indeed what we are doing then with additional partnerships, is to build a complete ecosystem around it, so that a customer can feel comfortable with the solution and that they know it's working, it's proven, we have tested it, and you have a reliable solution out of the box.
I was actually about to say, I'm guessing that this also provides that degree of reliability that people need in these kind of applications where you can't have a situation where you develop something and it takes a year to make sure that it's going to work and be safe. It's already safe from that design. We know it works, we know it's good, it's qualified. You can put it straight into your solution and effectively drive away.
Exactly. And one of the nicest things I heard a customer say is that, every time I switch on that inverter, it does what it's actually supposed to do.
Yeah. And it doesn't start up, have problems, and you try and diagnose the issue. Nope, it does exactly what it says on the tin first time it turns on.
Exactly.
Yeah. Now, There's one thing I just want to bring the camera across, which I believe is the CFO of your company. Is that right? In the
Yes.
passenger of that vehicle?
That's our Chief Fluffy Officer, actually, called Teddy.
So just tell us what's going on here, because this is quite interesting.
So the Electric Racing Academy, ERA, they have the world's first Formula 4 electric. It's a FIA-approved car, so it's within all the specifications. And they are using our inverter reference design. As you can see, it's exactly the same box bolted onto it for the second generation of drive unit.
And so what kind of gains and advantages are they getting from switching to an electric system?
Well, it's a completely different driving style, of course. It really needs an adjustment, and that's why the Racing Academy exists, really to train, first of all, make Formula racing more accessible. That's exactly what Formula 4 is for. But having it electric also brings down a lot of the headaches that the mechanics otherwise bring from a combustion engine and keeping it running.
That's actually quite interesting, because I suppose people like me are completely ignorant to how vehicles work. I mean, I understand how a vehicle works, but when you have an electric system, there's probably far less to go wrong in terms of mechanical components, whereas a combustion engine can be quite expensive, because I imagine for a Formula 1 car or Formula 4, it's quite a unique design. And so would you say that this brings the whole system cost down as well?
Yes, it does. And for the traditional Formula 1, for example, an engine is made to last 5 races, not more.
No.
And it costs millions of dollars.
5 races?
Yes.
Blimey.
And these things, these run around the whole year round.
Well, this will go until the battery dies, effectively, because it's all in the electronics. That's absolutely fantastic. So just one more question for you before we wrap this video up. For the audience who are currently watching, if they want to get involved with Cissoid Solutions, what would you recommend that they do?
Well, do get in touch with us. Find us on our website, cissoid.com. It's pretty easy to find us.
Fantastic. Thank you ever so much for having us here today. Thank you very much.